Today's lesson is about Introduction to Set Theory. A set is a collection of numbers or objects. The numbers or objects in a set are called the elements or members. If A is an element of a set P, we write this way. If A is not an element of a set P, we write like this. The set, this one, is called the empty set, which means it doesn't contain any elements. The number of elements in set A is written this. A set has a finite number of elements is called a finite set. Infinite sets are sets which have infinitely many elements. Set P is a subset of set Q if every element in P is also an element of Q. We write this way. Set P is a proper subset of set Q if every element of P is an element of Q, but it's not equal to. We write like this. Special sets, we use N stand for natural number. Z stand for integers. Z plus stand for positive integers. Z minus means negative integers. Q is a set of all rational numbers. Q plus is a set of all positive rational numbers. Q minus is a set of all negative rational numbers. R is a set of all real numbers. R plus is a set of all positive real numbers. R negative is a set of all negative real numbers. Remember, 0 is not positive and also it's not negative number. In other words, this 0 is not an element of Z plus. And 0 also is not an element of Z minus. The symbol U is used to represent the universal set under consideration. The complement of A, denoted A prime, is the set of all elements of U which are not in A. This symbol means the intersect of A and B and consists of all elements which are in both A and B. A union B is the union of A and B and consists of all elements which are in A or B. Disjoint sets. Two sets are disjoint or mutually exclusive if they have no elements in common. Set builder notation. Set A equals this. Raise the set of all x such that x is an integer and x is greater than 4 and less than and equal to 8. Let's look at the symbols and meanings of all sets. This symbol meaning is an element of. For example, -3 is an element of set Z. This symbol means it's not an element of. -2/5 is not an element of set Z. This symbol means it's a subset of, or it's a proper set of, which means a smaller set that is a part of a bigger set, like a natural set N is a subset of integer set Z. This symbol means A intersect B or A and B. Elements both in A and B. For example, if A is this, B is this, then A intersect B equals 2, -8. This symbol means A union B or A or B. Elements in A or in B. Like A union B equals 0, -5, 2, 3, -3, -8. A prime means the complement of A. Elements which are in universal set but not in A. Basically, we just do the subtraction. Subtract 0, 2, 3, -8. What's left? That will be a complement of A. Guided practice 1. Write using set notation. 5 is an element of set D. So we write down 5 is an element of set D. 6 is not an element of set G. 6, not an element of set G. 386 is not a subset of 1, 2, 3, 4, 5, 6. So we write down 386. You have to use this symbol. Then it's 1, 2, 3, 4, 5, 6. For number 2, find A intersect B and A union B. Write down the number of elements in set A intersect B. A intersect B means we need elements in common. So we have set A 6, 7, 9, 11, 12. B is 5, 8, 10, 13, 9. We have common 9. Also we have, that's the only element in common. So we write down like this. A union B. Every single element counted. We write down 6, 7, 9, 11, 12, 5, 8, 10, 13. Don't repeat the element. Number of A intersect B equals to 1. Question 3, true or false? This is a positive integers. Like you have 1, 2, 3, keep going. It's a subset of n. N means a counting number or natural number. You have 1, 2, 3. Keep going. Basically, these two are the same. This is a true because any set will be subset of itself. Look at the B. Rational number set is a proper subset of integer set. Definitely it's a false because rational number is not part of integers. Integer is a part of a rational number. Positive integer set union negative integer set is equals to all integer set. It's a false because 0 is not an element of z plus union z minus. 0 it's an element of integer set z. Let's go to guided practice 2. True or false? For A, 127 is an element of a natural number set. Yeah, this is true. 3 and 1/7 is not an element of a rational number set. This is a false. Which of these pairs of sets are disjoint? Disjoint means nothing in common. Therefore, for A, just check 3, 5, 7, 9, 2, 4, 6, 8. Yeah, this is a disjoint set. For B, P equals 3, 5, 6, 7, 8, 10. Q equals 4, 9, 10. Because they have 10 is the common element for both sets. Therefore, they are not disjoint set. For 6, set A has two subsets, empty set and itself. And then this set AB has 4 subsets, empty set, this set A, and this set B, and also the set AB. List the subset of A, B, C, D. Hence, state the number of subsets for each. Remember, empty set and itself always will be the subset of any set. So I have empty set and A, B, C, D. Then you can count. We can do the set with only one element, like A, like B, C, D. Then choose the set with 2 elements. I have A, B, A, C, A, D, B, C, B, D. Then you have C, D. You can list sets with 3 elements. I have A, B, C, A, B, D. Then you have B, C, D. Also, you have A, C, D. Now you can count how many sets together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 16 sets. If you only have one element, you will have 2 subsets. If you have a set with 2 elements, you will have 4 subsets. Number of elements in set A. You have 1, 2, 4. Number of subsets, we have 2, 4, 16. You could see the pattern. This is 2 to the first power, 2 squared, 2 to the fourth power. Therefore, if you have a set with 3 elements, number of subsets will be 2 to the third power, 8 subsets. If you have a set with 5 elements, you will have 2 to the fifth power subset. That means 32 subsets. Copy and complete this sentence. If a set has n elements, then it has 2 to the nth power subset. Guided practice 3. For the following sets, write down the meaning of the set builder notation. Write whether the sets are finite or infinite. Find the number of elements in each set. We read A as the set of all x such that x is integers and x greater than equal to -2 and less than equal to 1. This set is finite. You can list these elements in this set. We have -2, -1, 0, 1. Therefore, number of elements in A equals 4. For B, the set of all x such that x is a rational number and x greater than equal to -2 and less than equal to 1. This set is an infinite set. You cannot count because this x is a rational number, which means it could be decimal or fraction. Now let's go to number 8. Write in set builder notation. For A, the set of all integers between -100 and 100. So we will do this x between -100 and less than 100. This x is an element of z. For B, the set of all real numbers greater than 1000. We can write down this x. X is greater than 1000. And this x is an element of R. For number 9, state whether A is a subset of B. For A is an empty set. B is 2, 5, 7, 9. Yes. Remember, empty set will be subset of any set. For B, A is this. B is this one. Definitely not. First of all, remember A is a subset of B means A is smaller. And B is a bigger set. Because every element in A will be in B. For A, this A, you have -10. But -10 is not an element of set B. Let's go to C. Check set A. X is greater than equal to 0 and less than equal to 1. This x is a rational number. For B, y greater than 0, less than equal to 2. Y is a rational number. For this A is not subset of B, because not every single element in A is a part of set B. For example, this 0 is an element of set A, but this 0 is not an element of set B. Therefore, A is not a subset of B. Let's talk about complement. Any set in a set is a complement set equals an empty set. And any set union is a complement equals a universal set. The number of elements in A plus the number of elements in complement set of A equals the number of elements of universal set. Let's go to number 10. Find the complement of C given that universal set is integers. C equals x less than equal to -5 and x is integers. Its complement C prime equals. Learn how to write down the set builder notation. So we have x greater than -5. X is an element of integers. For B, union set is a rational number. Set C equals x less than equals to 2 or x greater than equal to 8. X is rational numbers. Complement of C equals x will be between 2 and 8. Then this x is rational numbers. Let's go to number 11. Suppose the universal set equals x greater than 0 and less than equal to 12. X is integers. Set A equals x greater than equal to 2 less than equal to 7. X is integers. B is x between 3 and 9. 3, 9 included. X is integers. For C, x between 5 and 11. 5 and 11 included. X is integers. List the elements of B prime. First of all, we need to list the elements for each set. Like U will be no 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. For A equals 2, 3, 4, 5, 6, 7. For B equals 3, 4, 5, 6, 7, 8, 9. For C equals 5, 6, 7, 8, 9, 10, 11. Therefore, for A, this B prime means the complement of set B equals. I cross out this 3, 4, 5, 6, 7, 8, 9. 1, 2, 10, 11, 12 left. For B, complement of set A intersect C. For complement of set A equals, I have to cross out that's 2, 3, 4, 5, 6, and 7. Then you will have 1, 8, 9, 10, 11, 12 for complement of A. Then check what elements in common for this complement of set A and C. This is C. You will get 8, 9, 10, 11 in common. Now let's go to C. First of all, you need to figure out A intersect B. Then you work out the element of this intersection. A intersect B, we need elements in common. So we have 3, 4, 5, 6, 7. Then the complement of intersection of A and B equals, I need to cross out 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. So you will get 1, 2, 8, 9, 10, 11, 12. Let's go to D. A union C. You will figure out this element in A union C. Then we already got the complement of set B equals this. Therefore, for this union, A and C intersect complement of set B equals 2, 10, 11, 12. Let's go to 12. Suppose universal set equals positive integers. P is a factor of 28. Q equals a factor of 40. First of all, list P and Q. For the P part, factors of 28, we do this. 1 times 28. 2 times 14 equals 28. 3 doesn't work. 4 times 7. 5, 6, 7 repeating, so I stop here. This number will be the factor of this P. 1, 2, 4, 7, 14, 28. For the Q, I will do the same thing. 140, 220, 3 doesn't work. 4, 10, 5, 8, 6, 7, 8 repeating. Therefore, for Q equals this element. For B, we need a P intersect Q equals 1, 2, 4. For C, P union Q equals this. For D, verify this is true. For number of elements in P union Q, that's 11. For number of elements in set P, that's 6. So 6 plus this one is 8. That minus 3 equals 11. Therefore, this is true.